Okay, I have here a couple different position time graphs that I'll work through here, and we'll see how the VT graphs look and the motion maps based on what we see on the position time graphs. First, we'll take a look at this position time graph, the first one here, and we notice that it has this strange kind of curve on it. And again, anytime we see a curve on a position time graph, that means that the slope is changing. And remember that the slope of a position time graph is velocity. So whenever we look at what the slope is and what it's doing, we're looking at what the velocity is doing. So I want to draw some tangents here to the curve. So that tangent if I can separate this, that tangent is about right there on the curve, very close to the beginning. So that looks like it's about here. So that looks very level, but a little bit negative of a slope. Not quite level, zero slope. Let's draw another tangent a little further down, maybe in this area here. I'll try to draw a tangent. That's pretty good there. And we see that that slope is steeper here at this point than it was at the first point. So the slope is getting steeper, but it's getting negative. So this is a negative slope that's steeper, which means that on our velocity time graph, this object is starting with a near zero slope, and that slope is getting more negative. So it's getting larger in the negative direction. I'm going to try one more tangent here that's in this area. And that tangent is going to be even steeper. Hopefully I can grab that and move it a little bit. There we go. So that tangent is about at this position here on the curve. So again, you see these slopes are getting steeper and they're getting more negative. So on our velocity time graph, what that says is that our velocity is starting near zero and it's getting more negative as time goes on. Now if you look at the next part of the curve, so this curve comes over and now it curves the opposite direction. Now if we look at some tangents to the curve on the bottom of this curve here, we see that this right here might be a tangent to the curve. Well, maybe it will cooperate and quit moving. There we go. So that is a tangent to the curve at about this point here. And you'll notice it's not quite as steep as it was here. So this one, it's very close to the same steepness, but this looks a little less steep than this one. And if I continue to draw more tangents to the curve, perhaps one right here, so that would be a tangent to the curve at about this point, and then another tangent to the curve maybe at this point. So again, that's a tangent to the curve around here. Now, what does this mean? We have a very steep one. This one's not quite as steep, and this one again is even less steep, meaning that our velocity is now getting less negative. It's less steep, and this is a negative slope. So our velocity is actually getting smaller, or closer to the zero value. Remember that your velocity time graph is actually a zero value for velocity on the time axis here. So that is then a velocity that's getting smaller, closer to the zero value, because these slopes here are getting less and less steep. Now, in terms of the motion map, we have a velocity that is in the negative here and here. All these are negative values, which means our arrows should be pointing in the negative direction, not the positive direction. We also, if we look at our position time graph, we see that we start at time 0 with a large positive position. So that means the object is over here, not at 0, but at a large positive position. So there's the object, and we see that these are negative velocities, and you'll notice they're small at the beginning, they get large, and then they get small again. So again, these slopes start shallow, get steeper, and then they get shallower again. So these arrows then are going to start short because of small velocity, and then they're going to get longer as we go. So a short arrow, a little bit longer, a little bit longer. But then they're going to start getting shorter again because these values are going to actually get smaller now as it approaches 0. So now the arrows are going to start getting shorter, and again, even shorter. So you see we have arrows that start very small, get longer and longer, and then begin to get shorter and shorter because our velocities start at 0, get larger, and then get smaller as time goes on. Now the second graph, you'll see we have a straight line here of constant slope, and that slope is positive. So for the first section of this graph, we have a constant positive slope, therefore we have a constant positive velocity. So the velocity now is staying at a constant rate, not increasing or decreasing, but staying the same value for a period of time here. Positive slope, positive value. Now, we see a curve on the second portion, and it appears that curve is getting less and less steep. So if you think about that being a tangent to this portion of the curve, and then if I try to draw another one here that's tangent to the end of the curve, right in this area, clearly you see that this is very steep here, and then as it curves over, it's less steep and even less steep, even approaching a 0 slope at the end of the time interval. So that means our velocity is no longer a constant positive, it's actually getting smaller and smaller and approaches 0. So our VT graph will look like that as it approaches 0 velocity. Our motion map then will start at a 0 position, because that's what our graph shows, that we start at the 0 position. So there's our object at first, and our object is moving with a constant positive velocity, so constant and positive. So we'll draw our arrows, constant length, in the positive direction. Then, the next portion, we see the slope is actually decreasing, so the smaller slopes then indicate that our velocity is getting smaller, and therefore our arrows should be getting shorter on our motion map. So now we'll see a couple arrows that are getting shorter, telling us again that this object at this point started to slow down and get slower and slower, and we might even put just a dot on the end showing that at the final position here we have 0 slope, therefore 0 velocity, and we have a dot with no arrow indicating no velocity. So I hope these helped.